Alright, here's a short video on the sigma notation homework since I'm not here today to answer your questions. So first it says evaluate each of the following. You must show your work to support your answer. That means that you need to use the series formulas that are on your note sheets. Okay, so let's start with number 1. I have the sequence 3x minus 6. It says find the sum from terms 4 to 13. First thing you need to notice is that this is arithmetic. You can get that based on the sequence formula that's in the sum. So you're going to end up ultimately using this sum formula. Right? Now, in order to use that series formula for an arithmetic series, you need to know a couple things. First, you need to know the value of n. How many terms are you adding up? So on our notes, we said that there is a trick that I like to use to find the number of terms. That is, you take the top index, 13, minus the bottom index, and add 1. Well, 13 minus 4 is 9, plus 1 is 10. So you're ultimately adding up 10 terms here. So that gives us n, but now I need to find what's a sub 1. Remember, a sub 1, I'm not actually finding the first term of the series, but I'm finding the first term that I'm adding up. Which here, since my lower index is 4, I need to find the 4th term. To do that, I just put 4 in for x. So I'll have 3 times 4 minus 6. 12 minus 6 is 6. So I know that's the first term that I'm adding up. Then I need to find a sub n, my last term that I'm adding up, which is the 13th term, a sub 13. Well, 3 times 13 is 39, minus 6 is 33. So you're adding up the 4th term to the 13th term, which are 6 to 33. Well, now you can go ahead and use the sum formula to show all of the work. The sum of these 10 terms is 10 over 2 times the first term we add up plus the last term we add up. You can carefully put that into your calculator. Right? So we have 10 over 2, or 5, you can do 5, times 6 plus the last term, which is 195. So if you added up all 10 of those terms, they would add to 195. And for these two problems, you need to show all of that work. For number 2, you have this time a geometric sequence. So ultimately, when you find the sum, you're going to be using this formula. Okay? Now, again, to use that formula, I need to know, first of all, n, right? N, we take our top index minus the bottom index plus 1. Well, 12 minus 7 is 5. 5 plus 1 is 6. So you're adding up 6 terms here. You also need to know your common ratio, r. Well, we can get r from the formula, which is 3. And you can actually find the first term, a sub 1, from this formula too. Because remember, the geometric sequence formula takes the first term times the common ratio to the n minus 1 power. So 2 is the first term. So really, you're kind of all set here. You have everything that you need to now go into the sum. So we need to find the sum of these 6 terms. Right? Oh, I lied. Oops, I'm so sorry. But we're not starting with 1 this time. Let's go back here. Our a sub 1 for this is the first term that we're adding up, not the first term of the sequence. And we are starting with n equals 7. So you actually need to find the 7th term, a sub 7. I'm so sorry about that. So we're going to put 7 in for n. 2 times 3 to the 7 minus 1 power. And when we type that in, we get 1,458. So that is going to go in for our a sub 1 in this formula, since we are starting with that term. So we again find the sum of these 6 terms. We're starting with 1,458 times 1 minus our common ratio is 3 to the 6th power all over over 1 minus 3. Well, we can carefully put that into our calculator. Make your fraction. Whoops. 1,458 times 1 minus 3 to the 6th over 1 minus 3. And this is your sum, 530,712. That is a big number. That's ultimately what you wanted. So for the first two problems, yes, you needed to show all of that work. For the next two problems, it says you may use your calculator. So you need to write sigma notation here, but then you can use your calculator to find the sum. So in order to find sigma notation, you need to identify what type of sequence are you using. So you have to decide, is it geometric or arithmetic? Here it looks like I'm multiplying by 4. So this would be geometric, right, with a common ratio of 4. Well, in order to do a geometric sum, you need to write the sequence formula for that geometric sequence. So here it looks like my first term is 1. We said the common ratio is 4, and it goes to the n minus 1 power. So it's pretty quick to write the geometric sequence formula here that's going to go next to the sigma in our sigma notation. The only thing that's left is to write the index values. Well, 1 is the first term. Start the first term, and we can just add up. There's no dot, dot, dot. So let's just add up how many terms we are adding. We have 1 term, 2, 3, 4, 5, 6. So 6 is the top index of our sigma notation. We can put that into our calculators. Remember, our calculator does sigma notation. We hit math and then 0, which is summation. Instead of n, you'd use x, and we're adding from terms 1 to 6. Now you just type in your expression. Remember to use x instead of n here, and the sum is 1,365. And that is what we're looking for, that whole expression. Last homework problem here. 12, 7, 2, dot, dot, dot to negative 28. All right, well, this is arithmetic. And it's arithmetic because each term here we are subtracting 5. So in order to do our sigma notation, you need to simplify this formula for the sequence. So we're going to find a sub n equals. Well, our first term is 12 minus our common difference of 5 times n minus 1. Now, in order to simplify this, you have to get rid of the parentheses, which means distributing the negative 5 and then collecting like terms. So you'll have 17 minus 5n. That is the equation. That goes into our sigma notation. So I'm going to lower this a little bit here. So we have our sigma notation, which is going to be sigma. Our expression is 17 minus 5n. We know I'm starting at the first term, but I have a dot, dot, dot. I'm going up to, adding up to the negative 28. I don't know what n is for that term. What term number is negative 28? We need to do a little work to find this out. So off to the side here, let's use the formula you just came up with. Let's take negative 28 and set it equal to that expression. Because that way, when you subtract 17, you get negative 45 is negative 5n, which tells you that 9 is the term number you're looking for. That means you're adding up 9 terms from term 1 to term 9. Now you are able to type that into your calculator because you have both indices. So math 0. We're starting at 1. We're adding up through the 9th term. And our expression is 17 minus 5x. When you add those up, you get the value of negative 72. If you need more help, good thing today is a work day, go ahead and work on the practice. There's a video for the practice on this as well. You can also go back to the notes video from yesterday or check the keys that are posted on campus.